Okay, so I got a couple things for you guys to work on today. Obviously, first you're going to start with this office mix. This is going to go over all three units that we've done so far. So the Pythagorean theorem, the special right triangles, and then all the trig stuff that we've done the last couple days. Once you get through this, so this one corresponds directly, all the problems on here are on that first worksheet that you guys are going to get. Okay, after that I have one that just goes over what we did yesterday. I want you guys to continue practicing that in terms of when we give you a trig function and when you're given a triangle to solve for the other 5 trig functions that go along with that. And then if you get through that, there's a quiz review for a quiz that you guys are going to take here pretty soon. So make sure you go through that. Make sure you come tomorrow ready to ask questions, and then we'll go from there. Pythagorean theorem we should be pretty familiar with by this point. Okay, remember a squared plus b squared equals c squared, where c is the hypotenuse. Other two sides do not matter. Okay, so if we look here, we go across from the 90-degree angle. Okay, that's where our c is at. So in this case, that's our x. So we're going to start with equals x squared. On the other side, doesn't matter what order those in. So we'll say 6 squared plus 9 squared equals x squared. That's going to give us 36 plus 81 equals x squared. 36 and 81 gives us 117. Remember, we're not looking for x squared, we're looking for x, so we got to square root that. Break that down. Okay, I'm going to go 3 and 39. 3 can't be broken down. 39, 3, and 13. Okay, both those can't be broken down. So I have a pair of 3's. So this is where a lot of you guys are making mistakes. Pairs go on the outside. 13 does not have a pair, so 13 stays on the inside. Okay, pairs on the outside, singles on the inside. Next one, same thing, except now we do have our hypotenuse. So now we're going to start with equals 16 squared. Other ones don't matter, so we'll go x squared plus radical 122 squared. When we do that, remember a square and a square root cancel each other out, so we're just left with whatever's underneath. 16 squared is 256. Now to solve for this one, we got to subtract. That's going to give us x squared equals 134. Square root both those. Okay, it's an even number, so I know it's divisible by 2. So 2 and 67. However, nothing goes into 67. So in this case, there are no pairs, so the answer is just going to stay whatever your square root originally was. Okay, it's just like this doesn't have a pair and this doesn't have a pair, so we multiply. 2 times 67 gives us 134. Okay, so your answer is radical 134, not 134. There's a difference there. All right, with the 45, 45, 90 triangles, remember these two equations only work for 45, 45, 90s. Okay, so the one equation is leg equals leg, and the other is hypotenuse equals leg radical 2. Okay, so the first thing I do is recognize which side of the triangle you have. So here's the hypotenuse. These two are just legs. We don't have to call them short or long because they're the same. Okay, so I have a leg, so I can plug that in for either one of those. And the other leg then is y. These are my two legs, so they're the ones across from the 45. So I know that's going to be the same thing. That's just 10. Then the hypotenuse is x. So I'm going to plug in x for the hypotenuse. The leg I know is 10. And then I always have to bring that radical 2 with. Okay, remember I don't want decimal answers. My variable is by itself, so I'm done with this. This one's just 10 radical 2. So it's really easy when you're given a leg. All you have to do is multiply by radical 2, which I don't want you to evaluate, and just leave that way. Now, things change for the next one because this time we're given the hypotenuse. We need to find the legs. So we have to start with this equation here now. And we're going to say 6 equals, and we'll just pick a leg, so x radical 2. Could have plugged in y if you wanted to. Divide by radical 2, so that cancels out, but whatever you do to one side, you have to do the other. Okay, so when we get to this point, we have 6 divided by radical 2, which is going to give you a decimal in your calculator, and we're not allowed to have radicals on the bottom. So we need to multiply by whatever this radical is. Okay, so 6 times radical 2 just leaves us at 6 radical 2, and on the bottom, radical 2 times radical 2 gives us just 2. Now, whenever you do this, there's one last thing you want to look for, and that is to see if you can simplify the outside. And we can, because 6 divided by 2 gives us 3. And then we don't do anything with the radical because there was no other radical to combine it with. Okay, so what we get here is x equals 3 radical 2. And remember, the legs are equal to each other, so if this leg is 3 radical 2, this leg is also 3 radical 2. Okay, so whichever side of the triangle you're given, you can plug it into these variables here. You have the hypotenuse and the legs. Now, the slightly more difficult one here. Okay, so with the 30, 60, 90 triangle, we have different equations. We have hypotenuse equals 2 times the short leg, and we have long leg equals short leg times radical 3. Okay, so one thing, if we have our 30-degree angle there, across from the smallest angle is the smallest side. Okay, across from the 90, just like always, is our hypotenuse, and then across from the 60 is our other leg, which is the long leg. Okay, so that's how you can tell which side's which here. Okay, so if I go up here, here's my 30. Okay, so I look, this is the only side I have, that's across from my 90, so that's going to be my hypotenuse. That's across the 30, so that's the short leg, and then that would be our 60 down there, so across from there is the long leg. So the only side I have is hypotenuse, so I have to start at the top there. So the hypotenuse is 8, the 2, and the short leg is y. Okay, I have to figure this out because my variable is not by itself, but it's a quick, easy step of just dividing by 2, and we get y equals 4. Now, the only other thing we need is the long leg. So, long leg is x equals, we just solved for the short leg, that was 4, and we always multiply that short leg by radical 3. Well, my variable is by itself, so those are my two answers. Up here we get 4 radical 3. Okay, the next one's a little different. Okay, so once again, here's our hypotenuse. That's our 60, so across from there's the long leg, which leaves us up here with the short leg. So in this one, we start with the long leg. So we have to start with that second equation. So we're going to say 6 equals, the short leg here is y, radical 3. Okay, so all we did is substitute in the long leg and the short leg into this equation because I had the long leg, and then we divide by radical 3. Just like on the previous side, you can't have the radical on the bottom, so we're going to multiply top and bottom by radical 3. So on the top, that's going to give me 6 radical 3. On the bottom, radical 3 times radical 3 just comes out to be 3. Once again, we're going to check. We can simplify that. 6 divided by 3 gives us 2, and then we still have that radical 3 we have to bring with. So y equals 2 radical 3. And then, to finish it off, we need to find the hypotenuse. So we're going to say x equals 2 times the short leg that we just solved for, 2 radical 3. Okay, so all I have to do is multiply these over here. When you multiply radicals, you multiply what's on the outside, you multiply what's on the inside. So the outside is 2 times 2, so we get 4. This is the only thing on the inside, so we just leave it by itself. So our hypotenuse is going to be 4 radical 3. Okay, so make sure you know this equation, and make sure you know which side of the triangle is which. Alright, trig ratios. SOH CAH TOA, SOHCAHTOA. Okay, make sure you know those, especially for the first ones. If you have them in order and you know there, the second ones will be easy. Okay, so we can see that for all these, we're looking at angle C. So that's the angle that we want to have. That's where we would put our theta if we wanted to. Okay, so for sine, opposite over hypotenuse. And we're going to backtrack real quick. Okay, I want to label all 3 of the sides here. So easiest one's hypotenuse because you're used to working with that. Okay, so that's going to be over here, across from the 90. Since this is the angle we're working with, across, or on the opposite side of the triangle, is the opposite side. And then the adjacent side is the one right next to it. Okay, so we got O, A, and H there. Alright, so for sine, that is our opposite over hypotenuse. The opposite is 30. The hypotenuse is 50. Okay, you don't have to, but you should simplify these whenever you can. The cosine is the adjacent over hypotenuse. Well, we labeled the adjacent over here at 40. hypotenuse is still 50. Simplify that down to 4 over 5. Tangent, opposite over adjacent. Okay, we said the opposite was 30. And the adjacent is 40. Once again, simplify down to be 3 over 4. No radicals in this one, so that's nice to make this pretty easy. Alright, now for these, okay, the cosecant is the opposite of sine, meaning that it's flipped. Okay, so that would be 50 over 30. So that's going to be the hypotenuse over the opposite. Okay, so 50 over 30 we can simplify down to be 5 over 3, which makes sense because our final answer was 3 over 5. Secant is going to be the cosine flipped over, which would be hypotenuse, which is 50, over the adjacent side, which is 40, which then simplifies to be 5 over 4, which makes sense because we had 4 over 5. And then finally the cotangent. Okay, tangent was opposite over adjacent, so cotangent is adjacent over opposite. Okay, the adjacent side is 40. The opposite side is 30, which simplifies to be 4 over 3. Okay, so the biggest thing with these problems is, one, making sure you know the ratios for all 6 of the trig functions, and 2, making sure you can label all 3 sides of the triangle. If you can do that, these will be really easy. Alright, so these start going over the notes that we were doing yesterday. Okay, so what we know is that the cotangent is 5 over 3. Right now that's all we know. Okay, so the first thing that we have to do, remember, is draw a right triangle. Okay, so that's all you're doing for the first one. Second step, you have to choose one of these two angles to be theta. I'll choose that one. If you chose the other one, it doesn't matter. Alright, third, we know that the cotangent of theta, cotangent is adjacent over opposite. So I know that the adjacent side of theta, which is down here, is going to be 5. I'll label that A. And then the opposite side is going to be 3. Okay, so I know 2 of my sides. Okay, once we know those 2 sides now, based on this ratio that we have, what we can do to get this third side, the hypotenuse up there, is we don't know the hypotenuse, so we're going to make that x squared. And then we're going to do Pythagorean theorem, 3 squared plus 5 squared, to solve for x. 3 squared gives us 9, 5 squared gives us 25, equals x squared. 25 plus 9 is 34. Okay, and then we got to square root both those. So we can break 34 down into 2 and 17, but that's it. And there's no pairs when we do that, so it just stays the same. 2 radical 34. Or excuse me, just radical 34. Alright, so now that we have all 3 sides of the triangle, now all we have to do is do exactly what we did on the last slide and just write down the ratios. So SOHCAHTOA tells us that sine is opposite 3 over hypotenuse, radical 34. We're not allowed to have that radical 34 on the bottom, so we got to multiply top and bottom, and we're going to get 3 radical 34 over, and then radical 34 times radical 34 just gives us 34. No more radical. The cosine is adjacent over hypotenuse. Adjacent is 5. Hypotenuse, radical 34 again. Multiply both those. We get 5 radical 34 on the top, and then just 34 on the bottom. Okay, now we get down to tangent. Tangent's opposite over adjacent. The opposite side we said is 3. The adjacent side was 5. No simplifying to do there. Now, all we're going to do is flip these here. You should know the ratios. Cosecant is going to be hypotenuse over opposite. So, remember, flip the original one. It's going to be radical 34 over 3. Okay, don't try to flip this final answer here. Secant, hypotenuse over adjacent, radical 34 over 5. And then cotangent, you get to end on a nice easy one because that's what we started with. Okay, so you should automatically know that one because that was the one that was originally given to you in the problem. And the last problem here. Okay, so this time what we're given is a coordinate. And to get to that coordinate of -4, +7, I have to go left 4, and I have to go up 7. To that point right there. So that's my -4, +7. Next, I'm going to draw a line between those 2 points. Okay, so this part is where a lot of mistakes start to come in, because remember, you have to use the x-axis to create your right triangle. Okay, so we're going to draw that line down to the x-axis here. We're going to continue across the x-axis, and that is where our theta goes. Now we need 2 sides of the triangle here to do Pythagorean theorem, which works out well because we started this problem out going left 4 units, so -4, and then going up 7 units. Okay, we can solve for all these sides as soon as we get the hypotenuse here, which we don't know, so our hypotenuse is x squared, and then we have -4 squared plus 7 squared. That's going to give us 16 plus 49 equals x squared. We add those up, we get 65 equals x squared. Square root that, we can break that down into 5 and 13, which then doesn't break down any further, so it's just going to stay radical 65. Okay, so I have all the sides. This is my theta here. So based on that theta, I know that my 3 sides are the opposite over here at 7, the hypotenuse at radical 65, and the -4 at the adjacent. Now there is a negative number here, so you have to make sure that you pay attention when you write that in your trig functions. You are going to put -4. Okay, so sine opposite over hypotenuse. Opposite side is 7. Hypotenuse radical 65. Can't have the radical on the bottom. So that leaves us with 7 radical 65 over just 65. Cosine now is going to be -4 over radical 65. Just like the first one, can't have that radical. That's going to give us -4 radical 65 over 65. Now tangent, okay, so tangent is just opposite over adjacent. So that one's just going to be 7 over -4. Okay, now we're just going to flip all those around, but you're still going to know the ratios. Okay, so this one's hypotenuse over opposite. Hypotenuse, radical 65. Opposite's +7. Secant, hypotenuse, radical 65 over adjacent, -4. And then last but not least, adjacent, -4 over opposite, +7. Now these can be simplified. Radicals on the top are perfectly fine, so we just have to leave it like that. Okay, so go through and watch any videos again that you might need to pause and ask questions up to your neighbor about. And then get this sheet, should be done, should be filled in already because I went through all the answers. Okay, start working on the next one, work on these problems with the coordinate planes and with the trig functions.